This is the scenario that we have developed in the project. In the demo, we will first acquire the heart rate and respiratory rate from the audiovisual system, and we will see how it is sent to the Raspberry. Then, we will do the same with the electronic part. After that, we will configure the Raspberry with the Android terminal in order to send data. Finally, we will show how the data is sent to the server and how it is visualized in the Android terminal. The idea is to compare our measure captured by the webcam with the BioPAC, a gold standard. We are using a bulb, as the fluorescent in the lab introduces other frequencies that distort the system. Now we are capturing a video with the webcam during a minute, the same time that the BioPAC measures. After video recording, we initialize the script that will run the rest of the program. First, we have the front detection and the acquisition of its coordinates. Then, we run MATLAB in order to obtain the green value of the front. And from this value, we extract the breath rate and the cardiac rate. Here, as a result, we have the mean value of the breath rate and the cardiac rate. Finally, we connect the computer with the Raspberry, sending the time of respiratory and cardiac cycles. That's the file that we have sent. As we can see, we have the time of respiratory and cardiac cycles in 2 vectors and in milliseconds. Now, we are going to check if our system takes the same values as the BioPAC. First, we load the values of the BioPAC and process them with MATLAB. Next, we look for the values that we have obtained with our system and compare them with the BioPAC ones. As we can see, they are not the same, but similar. However, the mean of a group of samples is nearly the same. The electronic system is composed by 3 different parts. We have a Raspberry Pi, a PVC that processes the data, and a sensor. When the system is ready, the red light is shining. After pressing the button, the green light will shine to indicate that the system is acquiring. When finished, the light will stop shining for a moment. Then it will shine again while the system is processing the data. As you can see in the screen, all the results are shown. And here it is, the Android app. We will first use it to configure the Raspberry. As we see in the screen, we must introduce the device code, name, user ID, device ID, doctor name, and medical center. When we press Configure, the Raspberry will be allowed to connect to the server. Let's see how the database works. First, we enter into the MySQL database with a password. Then, we look for the databases created by this user. There it is, the eHealth database. Let's use it. We will first show the tables that store personal data. For example, those that store users' information or types of measures. These tables are filled with the user's or device's registration. Therefore, they won't be modified very often. As we see in the last lines, the table that must contain the values received are empty. Now, we do it again to show how the data is sent. When the system is ready, we press the button. Then, the acquisition will start. When we finish obtaining the data, it is shown in the display of the terminal. Then, the Raspberry will construct the HL7 that will be what it is sent. Here, we can see it. To begin the transmission between the server and the Raspberry, the Antidote Manager must be started in the server. He listens a port, waiting for incoming connections of PhD. As we can see, he establishes a socket on port 6024. The manager receives the request from the agent located in our Raspberry to start communication, which in terms of x73 would be an incoming up to. Then, the device passes from unassociated to associated, operating, etc. When it finishes sending the data, the manager remains open, waiting for new connections. After receiving all data, the manager builds an HL7 XML file to save the measures and other patient info into it. Finally, he shows the doc created. These are the heart rate measures, and these the respiratory ones. Finally, we will see our data in the Android terminal. We set the username and its password, and then we ask for the data. And here it is. According to what has been seen, we can conclude that the system could be improved. However, it could perfectly be used as an eHealth device, so, in our opinion, we have fulfilled the objectives of the project.